My aim today is to try and reproduce a hubcap cover.
One of my quad bikes has got all four of these hubcaps missing. I'm going to remove this one off one of my good bikes and see if I can 3D print replacement ones in TPU, which is a flexible rubber type filament which I haven't used before. It may be good for this application. The rubber hubcap does a good job of protecting the centre nut and keeping the water out of that. It's nice to find something that looks near brand new under the cap. Let's go ahead and see how I go reproducing that out of TPU. I'm going to run through some of the design processes in making this hubcap. The first thing I've started with is a front view, which is this profile here of half the hubcap, which this profile here is going to be rotated to create the model, the base model for the hubcap. This little flap on the top that I've drawn, which is spaced 1 millimeter away from the main profile, is not going to be used as a solid object. It's basically going to be used later as a scraper to reduce the height of the text so that it follows the curve, but I'll come to that later. So that's part one. So part two, this is the profile that I've sketched in part one, and I'm using a revolve function to revolve that profile 360 degrees, which creates this solid body with that shape. Just a simple rotation. It's got the curved top, the other features that came together from that rotating profile. This piece shown at the top, which is part of sketch one, is not used until later. Part three is a sketch is done on the bottom face of the solid body now, and it's to include the scallops in the base of the hubcap. I worked out that the diameter of those scallops is around 25 millimeter. I drew one circle on the sketch in this location and then chose a circular pattern around the body using this as the center point and this is the feature, and 6 of those appeared generated automatically around the model. Part 3 is simply a new sketch on the bottom of the body. Step 4 is an extrude function which cuts away and creates the scallop in the base of the unit. It's used those 6 circles, and it's only using the little part that intersects the main body. It scallops that small section out, and it's only doing that to a depth of 5 millimeters, leaving a little lip on the inside there, which will be removed in the next function. If you look closely at this model, the scallop from the bottom is straight for the first 5 millimeters, and then it tapers in for the next 25 millimeters. And to achieve that function, that's what step 5 here does. It selects this little piece here, all 6 of them. It extrudes 25 millimeters, but not straight down. If it only extruded straight down, it would leave a smaller scallop in the tapered section above. What it's doing here is it's extruding a distance of 25 millimeters. It's minus 25 millimeters because of just the direction.
By examining the model and how it looked, it needed to be around a 20mm tapered angle, and I've found that 19.7 degrees taper angle left this scallop come down to meet the hip mark near the top. 20 degrees was slightly too much, as it turned out near perfect with those parameters. So that was a fairly complicated extrusion, but it worked and did an excellent job of reproducing those scallops tapering in to this band near the top. So the model so far has those scallops correctly positioned and matching the original quite accurately. The next step in the process is to hollow out the centre of this model, and I've used the shell command to do that. That's this one here. You need to specify a surface that you want to work from, and I've selected the bottom surface of the model, selected a distance of 4mm, worked to the inside of the model. It hollowed out my model with a 4mm wall thickness automatically. Now there's features on the bottom that need to be recreated now that I've got a hollow model. On this 7th step, the Suzuki logo was introduced to the drawing, brought in as a DFX file and scaled and positioned on this sketch, which is actually on the base of the model, not at the top. The model's shown looking down from the top at the moment. The Suzuki would be back to front if you were looking at it from the bottom, but it was brought in there so that it can be extruded through to the top surface in the next step. So in blue there is the sketch of the Suzuki logo. Those letters have been selected separately and extruded through the model effectively. The position has been, as it says over here, offset by 35mm, which raises where it starts to extrude from 35mm from the base, and it's gone a distance of 5mm above that, bringing the total height of that lettering 40mm off the floor. The top of that dome is 38mm high, so these letters are going to be shaved to match the curve in the next step. This is part of the first sketch that I mentioned would be used later. It's highlighted in blue there. On this step in the process, that profile is rotated, revolved. It's set to cut anything in its way. So cut is set there before a new body was set as the operation. In this case, it's set to cut, and the only thing it can cut is the lettering that was sticking too high, and the net effect of this is it rounds the top of the Suzuki logo to the same spherical shape as the top of the hubcap. That is a result of the last function, all the lettering, rather than it sticking up square as it was extruded from a flat surface, it is now chopped to match the curved surface. This is the 10th operation in the design of this hubcap. It's simply a sketch on the base surface of the hubcap and two circles, one 49mm in diameter and one 54mm in diameter, which this bottom circle there that you can see is the 49mm, and the 54mm is the inside size inside this rubber, the larger diameter inside, which matches the metal disc that this presses over on the bike. So those two circles have been drawn in, and for the next process of extruding the base features. This 11th operation has selected all the material from the outside of the hub there into the 49mm circle and extruded that blue section 6mm or 6.5mm in to join the outer of the hubcap. This 12th operation creates the larger diameter inside the lip of the base out to the 54mm diameter, and then it's extruded. It's offset by 2.5mm, which is the thickness of the lip on the bottom, and then extended a distance of 4mm in further, and it leaves a small lip. You can see one just there, which effectively sets a stop so that the cap can't go on too far, although it presses up against the wheel, so it can't go on too far. It's mainly this 2.5mm lip on the outside, which folds in underneath the big metal washer, effectively, that's on the centre of the wheel. There's just two minor additional operations. One of them is to put a big radius in the top of the hubcap on the inside. This is to help with the 3D printing so that there is a good transition from the wall to the centre, which reduces the amount of opportunity for filament to sag when it's unsupported in the centre of the hubcap while it's printing. It's purely there for printing purposes. The original rubber hubcap does not have that, but it doesn't get in the way of the nut that it's covering, so I've included that on in this operation, and it certainly seemed to work okay. The final operation was to put small fillets on all of the exposed sharp corners, which includes the dome top there, and there's a small fillet on these arches and transitions from this top band to the sloping side, and from the sloping side to the base and around the base, and each of these little fillets highlighting the areas that have been filleted. That is the final result with the filleting done, and it's now ready to be printed. The process of printing it is to export it in an STL file. It's currently a model within Fusion 360. It needs to be exported as an STL file, which is the type of file that the slicer needs to work with. Export has been chosen from there. It's using the file name hubcap version 5. STL file has been selected. There's a range of different file formats that can be chosen. STL is down the list. It's been selected here, and it tells you what directory you are going to save it in. Then you press the export button. Fusion needs to be connected online to create the STL file. The actual processing is done in the cloud. It can take 5 minutes at times, depending on how complex the design is, and then you end up with your STL file back on your computer in the directory you've specified. This is the hubcap model loaded into Cura, and Cura is a slicer which divides the model up into slivers or slices that can be, the information of each layer can be sent to the 3D printer. This little bar on the side here shows how the different layers are built up. I'll go right back to layer 1. Layer 1 has a brim, which is the light blue area around the base, and the yellow is the base of the model itself. The light blue creates a brim. I can show you there's a brim there on the printed piece when it's finished. That brim breaks off. It's only one layer thick. It's designed to break off, but it gives better adhesion of the model on the print bed. Now as you increase, I'll go back and increase that, you see after it gets up a few layers, about 4 layers, it starts putting infill into the design, and then it gets to another edge, and the yellow is edge work, and you can see the infill material building up. I think I've got 4mm wall thickness on this model, which is only 20% infill, which means that there's air space inside, which may help with the flexibility of the model. As it comes up, it starts to fill in the top. You can see the black or brown crisscrosses there are infill layers, and then it's completely filled in, and as it goes up further it starts to create the outside surface, and the lettering starts to appear on the outside until it reaches the top. So that's what the slicer does, and it generates the file that you take to your 3D printer. In my case it's an Ender 3, and we're using TPU filament. It also tells you down here in the corner the expected print time. It says 2 hours 58 minutes, and it's going to use 20 grams of filament, which is a piece nearly 7 meters long. This is the original rubber Suzuki hubcap. When I first produced the model for the hubcap in Fusion 360, I printed one out of PLA just to check sizing and any issues I might have, because I hadn't used TPU filament prior. I was pretty happy with the result of that. The only part that looks a bit dodgy is because the layers are built up on that dome top. You can see them quite clearly as circular rings, so it doesn't become as smooth as the edges of this PLA model. And there's also a seam down the side and across the top there, and there's evidence even of it inside, which I think can be avoided somehow. I need to do a bit of research to you either move a seam like that to another edge to make it less distinguishable, but they were minor issues with that sample print, but I was pleased enough with it to go ahead and print the TPU version. Now the TPU version doesn't print as smooth on the near vertical walls, and the rings on the top also are not as well defined. The Suzuki logo is difficult to make out, but overall that fits the bike correctly, so it's a successful reproduction. That's the original hubcap. This is one I've printed. The texture on the top is such that the Suzuki logo is barely visible. This is printed out of TPU. It's got a bit of flexibility to it. Possibly not quite as much as the rubber one. This is the first attempt I've had at fitting my printed one. We'll see how it goes. Oh, well, that's it fitted over the hub nut, so I don't know whether the original is as loose as that one is. I think it's going to take a bit of mucking around to prise it off again, but it pressed on nicely. So that's a win. Contact me if you want the STL file. Get out to your shed and have some fun in the meantime.